You plug in an Ethernet cable. Nothing happens. You try another cable, still nothing. The network doesn't care about your frustration because the physical layer has rules, and if you break them, there is no communication. Welcome to Ccna Chapter 3, Cables, Connectors, and Ports. This is where networks actually begin. Not in software, not in configuration, but in the physical wire connecting two devices. Before we get into cables, you need to understand why all this works at all. Your Dell PC talks to a MacBook in a Starbucks across the world. Different hardware, different ISPs, different everything. The answer is standards. The IEEE, the Institute of Electrical and Electronics Engineers, defines the rules. IEEE 802.3 is Ethernet. IEEE 802.11 is Wi-Fi. Without these standards, every manufacturer would build their own incompatible network, and the internet as we know it would not exist. Now, what actually travels down these cables? Not letters, not words, bits, zeros and ones. A bit is a binary digit, the smallest unit of information. 8 bits make a byte. On copper, a 0 and a 1 are represented by different voltage levels. On fiber, they're pulses of light, but they're always bits. Network speeds are measured in bits per second. Kilobits, megabits, gigabits. 1 kilobit is 1,000 bits. 1 megabit is 1,000 kilobits. 1 gigabit is 1,000 megabits. For the CCNA, use base 10, not base 2. 1 kilobit is 1,000, not 1024. Let's talk about the cable you're most likely holding right now. Copper UTP, unshielded twisted pair. 8 wires, twisted into 4 pairs. The twisting reduces electromagnetic interference. The connector at the end is called 8P, 8C, 8 position, 8 contact, though most people just call it RJ45. Ethernet over copper has standards. Each one has a speed name and an informal name. 10 megabits per second is 10 base T. 100 megabits is 100 base T. 1 gigabit is 1,000 base T. 10 gigabits is 10 gigabase T. All of them share the same maximum cable length, 100 meters. Here's where it gets tricky. 10 base T and 100 base T only use 2 of the 4 wire pairs, pins 1 and 2 for transmitting, pins 3 and 6 for receiving. 1 gigabit and 10 gigabit use all 4 pairs. So if switches transmit on pins 3 and 6 and receive on 1 and 2, but routers transmit on 1 and 2, what happens when you connect 2 routers with a straight-through cable? Both sides transmit on the same pins. Nothing works. That's where crossover cables come in. They swap the transmit and receive pairs, so pins 1 and 2 on one end connect to pins 3 and 6 on the other. 2 routers can finally talk. But here's the good news. Modern devices have Auto MDIX. The device detects the mismatch and reverses its pins automatically. You can grab any cable and plug it in. Still, the CCNA will test you on straight-through versus crossover, so know the difference. Now, what if you need more than 100 meters? Copper can't do it. Enter fiber optic cable. Fiber sends light through a glass core, not electricity through copper. It uses 2 cables, one for transmitting, one for receiving, connected to an SFP transceiver. SFP stands for Small Form Factor Pluggable. And yes, they're expensive. There are 2 types of fiber. Multi-mode fiber has a wider core and uses LED transmitters. Light bounces at multiple angles. Maximum distance, several hundred meters. Single-mode fiber has a narrow core and uses laser transceivers. Light travels at a single angle. Maximum distance, tens of kilometers. So when do you use which? Copper UTP for end hosts, PCs, printers, anything on the same floor. It's cheap, it works, and 100 meters is usually enough. Fiber for infrastructure, connecting switches between floors, between buildings, across cities. Fiber is also immune to electromagnetic interference and doesn't leak signals, making it more secure. Here's what you need to remember for the exam. Standards make communication possible. Copper UTP uses RJ45 connectors and maxes out at 100 meters. Fiber uses SFP transceivers and goes much farther. Single mode goes the farthest, but costs the most. And auto MDIX means you probably won't need to worry about crossover cables in the real world, but you will on the test.